Excellent.
Because it's Cassandra. And it's 3.0. All right. Thanks for warming up the mic, Renee. I like that. You're a true MVP. All right. Let's see, where's my presentation? Here it is. So thank you everyone for braving the weather. And I think it's funny because this is about as bad as the weather gets here, right? This is like emergency. My phone's been going off all day. Oh, emergency situation. It's just raining, right? It's not that bad. I mean, there's people from anywhere north of, say, California that see real weather, right? Anyone from Canada? That's a loaded question. There's a lot of Canadians in here. So yeah, you know what happens there. This is a joke. One of my favorite airports, Chicago, not really. I was going to Toronto and I had to go through Chicago. Almost didn't make it in because it was snowing a little bit. It was a complete blizzard in Toronto and no problems at all, no delays. They're just landing planes in this whiteout sideways snow. And they're like, what? It's just snow. It happens here all the time. It does in Chicago too. I'm supposed to not talk bad about Chicago. Sorry, Pete. But anyway, I'm not here to talk about bad weather. We'll get plenty of that later on. So I'm going to talk about data modeling, which is a surprise. I realize I've been talking about data modeling on not this particular stage, but at Netflix for 5 years now. I need a new career. But it's because it's changed so much. And so we have to, those of you, how many of you were using Cassandra 5 years ago? Oh yeah, there's some tepid hands. That was one thing, right? Thrift. That was Netflix. We still use Thrift. But data modeling was a different problem back then. So I did this. This is a Cassandra Summit in 2012. This is like a Wayback Slide, and it looks kind of old-fashioned, doesn't it? No, it's Keynotes, but that was back before we invented 6x9, 16x9 format, the widescreen format. Everything was 4x3 because we used VGA connectors. Let me tell you, kids, it was rough. But I did a talk on building an application with Cassandra. And this thing was called KillrVideo, and this thing still exists today. I wrote up a spec for it and showed people. There was a cat picture because I hear those are cool, and they still are. My daughter, she likes to follow cats on Instagram. She doesn't have an account yet, but apparently cats have accounts on Instagram. I feel so behind. But a video sharing website seemed pretty realistic, and we still have it today. But what was, this looks normal. What doesn't look normal is the code that it took to get data in and out. This is Hector code, and I'm really glad Nate's not here because he'd probably throw something at me. But it was really hard to use. I mean, you had these mutators where you add insertions, where you had a factory, where you create a single column and you give it a name. Thrift, if you've never used Thrift before, the data model was what you put in the database. You just throw it in there. There you go. So what's the data model? Well, let's go look at your code. That's how we did a data model exercise, is looking at code. And when you wanted to get the data out, you kind of had to know what columns were in there. Great, because it acted like a key value store. Bad, because it acted like a key value store. And there was some limited typing, but it made it really difficult to be expressive in your data model when you're trying to work through your application. When you're building an application and you try to build a data model around it, there was no way to express that data model other than writing some code. So again, here's the old guy picture. Get off my lawn. You are so lucky now. This is a better world we live in because we have CQL3. Yay! And why CQL3? Because 1 was a joke. 2 was a bad idea, and 3, we stuck the landing. Ironically, here's the ironic story. I love trivia. So the guy who coined the term NoSQL His name is Eric. He's a committer on Cassandra. And he's the one who said NoSQL. Wow, no SQL. Guess who invented CQL? Eric. Yeah, we still give him a hard time about that. Did you know that, Sandkel? Next time you talk to Eric, you can ask him. So KillrVideo is much better off. I gave it to somebody else to build it better. And it's actually using, right now, hats off to the Netflix team, it's using Falcor and microservice framework. Falcor is a project that's from Netflix, nice open source project. But it's all built in different code. We have different code bases, and you can go check it out. That's a shameless plug for a reference application that's really cool. I did not write it, but it is a real thing. We think we're going to pass up Netflix traffic any day now. You guys don't. You can use any of the code you want, really. So I'm going to just walk through like what CQL3, which is the spec version, and then Cassandra version. It may or may not be interesting, but I'll try to make it that way. So in Cassandra 1.2, which seems like a good time to release a major feature in the dot version, we got rid of CQL2 and we started doing only CQL3. This is what you're using today. And it gave the empty in, custom links, custom secondary indexes. Okay, not so sexy. All right, 3.1, a little better off. Now we have some really interesting things because with Cassandra 2.0, we're getting lightweight transactions, and that's Paxos. So we can do things like exclusive operations for if insert if not exists and update if, delete if. So all these new things were added to the syntax because we want to support lightweight transactions. And those are very popularly used today. In Cassandra 2.1, we started expanding the use cases inside the CQL spec for more for application development. First was user-defined types, and user-defined types are probably that was one of my favorite adds in the CQL spec line for a lot of reasons. But I use them quite a bit in my examples. There's some other indexing, and then tuples. Has anyone ever used a tuple in Cassandra? It's a type. Still nobody. All right, I'm gonna Twitter that. I bet you still nobody. The fun here, because we're all friends now, and I've told you some trivia, that trivia is the developer who is working on user-defined types said, hey, you know what's interesting? These tuples, I can just expose that because I'm using them inside the code base. And so no one said no, so he did. That was Sylvan, by the way. And just expose tuples. Here's a new type that no one will ever use in a million years. So there you go, you're welcome. But user-defined types opened up an interesting avenue for what you can do with data modeling. Because with types, now you can create complex types to use in your data model. So instead of having a table that has, say, some metadata in it and having to do some in-application joins, which is kind of an evil thing to do, you could co-locate that data and denormalize it into the same data set. And what was really cool is creating sets, which gives you a one-to-many relationship. So you can see here, I have this video metadata, which is a set. So I can have one video record, like this is a video, but then I can have metadata and have multiple, and it's 0 to n versions of that. And it gives that kind of that one-to-many feel in a denormalized set, which is great. It makes it easier for me to understand the code. And the frozen syntax is there because you can't modify it after it's done. But I believe that that's probably what you want to do anyway. If you're into immutable data, this is a good thing. But now inside here, you can see that all these things are now supporting that video table in one shot. Like where it is, it's on YouTube, it's on the name of it, the description, the tags, even the metadata to display the preview image. That's kind of weird, huh? See the connection here? All right, never mind. Now, Cassandra 2.2 was kind of a funny release. Again, more trivia. I don't know if you know this, but 3.0 was supposed to come out. And as big monolithic releases go, it was taking a long time to get out. And the decision was made to release 2.2 so we could get some features out into the wild so that people could use them before having to wait too much longer, because there were some things that needed to get fleshed out. For instance, user-defined functions, which I like to point out first and foremost. It was not the tiny int or small int. No one was worried about that. Those are nice. And then date and time were now types. They weren't before, which was kind of weird. But the user-defined functions gave us user-defined aggregates, which gives us aggregates. Why is that important? Well, let me show you. So I have a table here that is video rating. And video rating was just, when you click on how many stars you want, 5 stars for that. Well, it was a counter column. And so what it's doing is it takes a video right here, the one particular video, and then it takes the rating counter, like how many times someone has rated it, and then the total, which would be adding up, like you said, 4 stars, and the next person said 5 stars, the total would be 9, and then the rating counter would be 2, so you say 9 divided by 2, that's your average rating. Ah, math. But that required you to do that in the application. Granted, not the most complicated application logic, but we could replace that with a user-defined function. And what this does is it gives us an average rating in one call to the database. And this is not anything new if you've worked with a database in the past 30 years. These are also, I'll tell you what they're not, are stored procedures. I mean, if you've ever worked with stored procedures in like Oracle, people get stupid with those things. They write entire applications with stored procedures. That's, laugh over here. Because you probably, Oracle Forms pretty much was like inside the database. It's like nice, but it really knew if you were a DBA, you hated your life after that. User-defined functions are not that horrible, right? They are a very clean, pure function, meaning that, for instance, this language Java, you can use other languages such as JavaScript, Ruby, if you're into that kind of pain, Python because it's cool, but anything that's supported by the embedded language type for Java, and of course Java, which I use, but it's just a pure function, meaning that it takes types and returns directly without making any external calls. And you can't do any imports. That sure limits what you can do, which is good. If you can imagine creating a type, user-defined type to say, make like an HTTP call to an external website, I don't know if I want to put that in my read path. That wouldn't be good. And so this just keeps it so that you're doing things like calculation, string manipulation, that sort of thing. In this case, what I'm doing is I'm taking 2 types, these 2 counters, rating counter, rating total, and I'm just dividing them and returning that double back as a return type for this. Real super simple. So whenever I do the actual select, I say select average rating and I pass it the counter and the total, I can get that back in a single call from the database. Again, nothing groundbreaking, but this is kind of, in my opinion, this is table stakes for a database. You should be able to do that. And it embeds that logic, like I can say it's part of the data model that I am creating an average rating with this table. Now aggregates, we already have some aggregates that are built in, and so for instance, we can do a count. Now I know count doesn't seem that complicated, but what's the first thing someone does when they spin up a Cassandra cluster and they go into CQL and they select count star from table name? That's unfortunately a total anti-pattern, right? If you have a billion partitions and you select count star, how much are you going to get back? Pop quiz. Anybody? Oh, come on. You were just in our class. I'm going to pick on you. Is it 10,000? It would be. It's 10,000 because that's when it limits out. It says, sorry, no more. I'm cutting you off. Heard that a few times. But at 10,000, it stops you from doing something really stupid. And it's one of my favorite questions. You see pop up in user chat is new users come in and say, it's broken. It says there's only 10,000 records. Cassandra sucks. I hear that a lot. Oh, yeah, you should have seen it. I put it on a T1 instance, and it didn't work. Cassandra sucks. No, it doesn't. But when you say it returns 10,000 records, it's because you're actually asking it to do a full cluster scan, and that should be a Spark job. But what really makes sense, it does make sense, is whenever you do a count on a single partition, because that keeps it node local. You're actually not traversing the network, and you're just going to be looking at one single file. So count is a function that works really well in this. There's also an average function and a min and a max function. All of those are for a single partition. Those are built-in aggregations to Cassandra. So if you use those right out of the box with Cassandra 2.2, you are good to go. Now, the reason you're all here tonight and you braved all the weather is 3.0. And it's really funny because I just did a poll on Twitter, and I'll look to see where it's at. Where is everyone at with what version of Cassandra are you using? You guys off of 1.0 yet? No? Yeah, all right. Okay. No. Funny story. My first day at Netflix, I had to go figure out, and Christos remembers this, 1.0.9-VJ.
Yeah.
Yes.
It's a great version.
It was a great version.
Rock solid.
It was compiling on his desktop. All right. So 2.2, I'm doing this poll right now. There's 16% of respondents are saying they're using 2.2, but now 30% say they're using 3.0, which is a big up from the last time you did it 6 months ago. So 3.0 is becoming the predominant version. Still though, you love your 2.1. 36% of you love 2.1. And the rest of you are just sad you're using less than 2.1, 18%. So 3.0 is starting to become a de facto version. Now with 3.0, it started the much maligned and definitely debated TikTok release format, where one would be a feature, .1 was a feature release, even was a bug release, et cetera, et cetera. And it just kept doing that every month. And then there's a 3.0.x release, which is not feature, but bug release. Confused? Well, don't try to figure it out because it's all changing anyway. So with 4.0, TikTok is dead, but in 3.0, you'll have to deal with this. Right now, we're on 3.9. 3.10 is getting, please ship 3.10. Somebody in here is not okay with that, and I'm not going to name names. But if you're going to use Cassandra 3.0, or 3.x, try out the 3.0 first, because that's the most stable portion of this. And if you're interested in looking at what 3.9 is doing, there's some really cool features in there. So I'm going to cover what those are. Now, first, the cast operator, which, again, is like, oh, that wasn't there before. Now it is. There's a per partition limit. How much data you can put in, but most important are the last two, which is a materialized view and SASE. SASE is another acronym that you will learn, and you'll love it. So let's talk about materialized views. Materialized views are not exactly the same as what you do with a relational database, where like a materialized view in a relational database is more or less an SQL command that gets turned into a table, right? And like with Oracle, you can do it refresh on a certain time frame. Materialized views in Cassandra are a table that express a denormalization in real time. And so in this case, I have this table of videos, but what if I want to look up by location, right? If you know Cassandra SQL, looking up a random column and looking up the data inside of it, that requires a secondary index, or using something like DSE with search on top of it, or worse, creating an analytics job, which none of these are sounding as appealing as just looking at the column name. Now, what you would do in typical CQL fashion is you would create your own lookup table. And this is a roll your own video by location. And what that requires is that you're denormalizing the data into a different table, and you have to maintain both tables. Meaning, I insert data into videos, I'm going to have to insert data into videos by location. If you delete a video, make sure and delete the data out of videos by location. So that's a little bit of a PETA, but it's been working for a while, and it's just part of the rule set. But what if Cassandra could do it for you? Now, for new users, you probably think that's pretty awesome. It's like garbage collection when I first started using Java. I thought it was really cool. I don't think it's cool anymore. Ever. All right, so I'm back to C++ now. So the create materialized view, videos by location, now what I'm having Cassandra do is do it for me. So much like with a materialized view in a relational database, I have a select command. So I'm selecting some columns from videos, and then I have to specify where the video ID is not null and the location is not null, because my primary key is location video ID. Now, if you're familiar with Cassandra data modeling, you know that the location is the partition key and the video ID is the clustering column. So I've now created a pivot of that data in video that is more specific to what location is. So now I'm creating a large partition, a wide partition of locations with a bunch of video IDs, multiple rows of video IDs. That's a proper data model. But what you get is that when you insert data into videos, it will automatically insert the data. It'll migrate the data over to this videos by location table for you. Question that I'm sure is rolling in your head right now, but when does that happen? It is eventual. It's part of the eventual consistency game that you love to play, but it synchronizes it asynchronously. So whenever you insert data into video, it happens asynchronously. It will happen, but it's not instantaneous. It's not an ACID transaction, and it's not atomic. That's just the rules. But it does do the job, and it is a lot easier than trying to manage it in your own application code. And there's some optimizations that we can do as well. So I'm trying to remember what all this is about. So if you're doing a write into it, that's when you start seeing performance hits. So the more you add with one materialized view, it's going to take X amount of time. With 5 materialized views, it's going to take even more time. The hit is on the right. Yes, question.
Are these materialized views, is it co-locating the index with the data, or is it partitioning it separately?
Thank you very much. That's a good question. These are actually tables in Cassandra. So underlying, if you look at the actual table structure, these are tables that we're creating automatically. So it's not an index. It's an actual table. So it follows the same rules as a table. So on the right, where there's a hit on speed, so that's going to be because it has to write to 5 different tables. The read is actually much faster because you are going to be reading directly from a table, a real Cassandra table. It's not going through an indexing scheme. If you were to look at, say, using secondary indexes, you're going to get a performance hit. This is something I tell people all the time. Secondary indexes are for convenience, not for speed, because it has to go look at all the different indexes to find your data. Whereas with this, it's an actual table. You give it a partition key, like a location, it will go to the node that has the data and find the SS table that is responsible for it, just like if it was in the video table. Is that good? More? All right. I'm asynchronous too. So now whenever I do a select, say I've inserted a bunch of videos into my system, when I do a select location of video ID from video by location, I get a table of data out. And that's coming from all these different partitions are going to be just like a table where each partition is going to be sitting on its own node. So that works pretty well for me. SASE, which, by the way, was the #1 talk at Cassandra Summit by a lot, because it's a different type of indexing scheme. And again, with variety comes all these different caveats, right? So a user example, user table example. What if I want to do the lookup by any one of these other like text characters, timestamps, things like that? Well, again, with a relational database, we would probably add indexing to that because we want to be able to look up. You can do it without an index in a relational database, but to speed up that lookup, you need an index. But for Cassandra, we need an index to look up that data without any other data. So if I wanted to say, give me everyone with a first name of something, well, SASE is going to help me do that. So what is SASE? Why am I just using an acronym? Because here's the real word: storage attached secondary index. SASE's cool, right? But this tells you kind of what it's doing. Is that we're attaching a secondary index directly to the SS table, so it's a little more co-located. So whenever you're looking for specific data, it's a fast index lookup, and that's what it's built for. The other thing that it's meant to do, and I think probably the first question a lot of people have in their mind, is when you look how it works. Now, what about something, so like, let me give you an example, and then I'll try to counter it with something. If I have created a customer index on user, what I'm doing is I'm using different types of analyzers on the data. Now you'll notice this is a non-tokenizing analyzer with case-sensitive faults. That is looking really close to like Lucene, right? It's tokenizing or not tokenizing, case-sensitive. That is kind of in that square text parsing type indexing scheme. And that's more or less what SASE does, is that it indexes the data, not just is the data there, but it also indexes the text data inside of it. It is a lightweight search tool for that kind of thing. And so in the case of like text or first name, what if I only want to look up like the first few letters of the name, and I want to find all the records with that? That's what it's good for. There's different ways to do this. So I'm like, for instance, I'm turning off the case sensitivity here. Here's another one on last name where the mode that I'm going to do is contains. So now I can look for characters inside of a last name. And for time data, I can use an index called sparse, which is specifically built for time series data. And all of these do, what these really do is give you the ability to find data in your cluster quickly without having the overhead of what secondary indexes do. They're meant to be fast. And they do include a query optimizer to make these better. So how it works is whenever you write data into the system and you write it into the Cassandra node, which goes into the mem table, when the mem table flushes out the SS table, it also does an indexing operation on the data, creates a SASE index for that data, and it co-locates it with the SS table. And I got a bug in my slide. It should show the SS table with the SASE index. Hang on. Like that, but with this. I got to fix my bug. So now you have like a one-to-one match. And as you know, if you do know, reads from an SS table are indexed by partition index. So you know which partition has the Bloom filter partition index. They narrow you down to a single file on the system, if possible. Well, if you're already there, you should just look at that one index file as well. If you were using something like Lucene, you would have to create all the Lucene index files that are associated with all the data on the node. I know that because we do that at DataStax. But it's a much bigger problem. Now, I have some caveats with this too. So the query, let's say that I have this record right here. This dude looks kind of familiar. But what if I want to look for, I create those SASE indexes that I created before. How would I use them? So I can say select star from users where first name like PAT, and then, hey, that's a like operator. That's what you get with SASE. This is a new operator, and a like, I know you missed it, now you have it. And it works just like you expected, where you have the %, and this gives you a prefix search. Now, if you recall, I created a contains search before. Now, oh yeah, and I also did it case insensitive for here, so I can use any combination of uppercase, lowercase, it doesn't matter. And then this one is just the first or the 3 letters in the middle of my name. It will find that as well. So everyone with Thad in it, probably 1 in the database. Oh, there he is. And in the case where I want to look at just for email addresses, but then time series data right here. When I'm doing a scan on my time series data, I love your big screen, by the way. You can actually see all these. It's great. When you're doing a time series search where you're looking at a large range of data, that sparse index makes a faster lookup for that. So with any new feature comes the good and the bad. So when to use SASE? When you have these multiple fields to search, that was what we did here. You're not looking for more than 1,000 rows returned, because you're starting to get into more of an analytics style job at that point. It should be, I want to look for 1 record, 2 records, 5 records, not 10,000 records. And you know the partition key. Again, the partition key is important because if its SS table has an index with it, you want to co-locate those together. Using the partition key is going to put the read on the SS table. If it's just a general go look at my cluster and look for data, it's going to be slow. And indexing static columns is made of win. Static columns, of course, mean that there's only 1 record, 1 value inside the SS table. Indexing that 1 value gives you a lot of speed. So indexing static columns is awesome. Here's the don't. And this is the one I want you to pay attention to, because when you're going to do it, and then you're going to say Cassandra sucks. So searching large partitions, it's not a replacement for what Lucene can do. Lucene's pretty freaking awesome, right? It's been baked for like 20 years or something. And it's still the most unreadable code base I've ever seen. If you have a really tight SLA on read, and it's because with an index read in a distributed system, you're still looking at latencies because you're asking for data here and there. So rewind, materialized views are fast for reads, but slow for writes. SASE is fast for writes, slow for reads. So opposite of each other. If you're using search for analytics, bad idea. And ordering, that's kind of a Cassandra thing. If order is super important, then you build it into your data model. Don't ask your query to make it for you. So that is all I have. Good timing, almost 8 o'clock. So some more questions? You had a good question back there. Anyone else? Pictures? Oh, yeah.
Can you give an example of
A static column?
Can I give an example? Like, where would you use a static column? Well, in the video table. All right, so first of all, do you know what a static column is? All right, that's probably more important. A static column is whenever you create a data model, every one of those columns will be repeated if you're using a clustering column, partition key, clustering column, and the primary key, all of those columns will be eventually repeated throughout the file, the actual physical file. A static column creates 1 record next to the partition key and no others. So it's an optimization on storage. So think of like in a video, the video ID or video by location, right? If you had a location that was a partition key, maybe you had the latitude and longitude as a static because that location isn't moving, right? Or the name of the location would be a static. But every video would be a part of a clustering column. You just get 1 value in that static column, perfecto. Does that help? You had a question over here.
How do we compare whether to use SASE versus the materialized view? If I want, let's say, search by one of the fields, how do they compare to each other?
Well, all right, so the one I mentioned was that if you need fast reads, you use materialized views. And if you need fast writes, you use SASE. But that's just the speed considerations. The use case considerations are much more specific to the data model. So materialized views will give you a partition key that you can look up by with a clustering column to do a scan. Okay, that's what you normally would do with a Cassandra table. SASE gives you that much more rich, interesting, crazy. You can do wildcard searches. The like operator is what you're opening up. So that data model is very, very different from what a materialized view can do ultimately. Because a materialized view, you can't run a like on a materialized view.
In terms of storage, how much SASE takes? I think.
Good question. All right, so this is something to really consider. This is an index. It has to create indexes to do this work. You could blow up some big indexes with SASE. If you're using the tokenizing case insensitive, I mean, you just use every single bell and whistle in that index. It doesn't take much to make that data blow up. Like it contains means it has to tokenize every single character. And that index could get pretty big. That is a consideration for sure. That's why whenever you get into that edge where you're starting to do more of that kind of stuff, it's probably better to use something based on Lucene, which uses something like doc values, which are a lot more efficient. But that's a larger data set problem.
Yeah. Now, regarding materialized views, what about the historical data? If I created a view after already data exists for some time, then
it'll start migrating that data in. Yeah. You'll start seeing the materialized view being created with that data.
For the existing data as well.
Right.
Okay.
Anybody else? All right, we'll get that last pizza. Oh, wait, hold on.
One super quick.
No more pizza.
What's the largest partition that you typically would recommend a non-blown up SASE index on? If that makes sense for your average index size.
Yeah.
What's typically the largest number, the largest partition size you'd recommend?
Largest partition with SASE or without?
With SASE.
With SASE. Okay, I'm just making sure I got all my requirements. Yeah. With SASE, largest partition. The depends is going to be on the type of indexing you use, but let's say that you have a gigabyte partition,
Sure.
Pretty good size. If you're using it to contains, potentially that could grow that partition much bigger. I will tell you this, it will depend a lot on what you're trying to do with that read data. If you don't care so much about that, your SLA is not so tight, then 100 megabytes, a gig of data, wherever you say enough, right? It will eventually time out. I don't know exactly where. It's just based on whatever data stored in there. But that's the consideration. And there's going to be a point where you just rather use something like Solar, or Elasticsearch, and Lucene, and go on with your life. And doc values are cool. I really dig the doc values lately. All right, next question. All right, now I can say it. Grab your last piece of pizza. Be safe out there. It's crazy, and I'm driving too, so don't hit me, okay? Thank you, everyone.